is a term that describes a functional object or system that cannot work without all of its parts being in their specific location and present at the same time. This means that if one part of the object or system is missing, it will not work at all. A simple illustration of an irreducible complex system is the mousetrap. Without one part of a mousetrap, such as the spring, the catch to hold down the trap bar, or the board to hold all the parts down on, the mousetrap has no beneficial function, and the mouse gets away with the cheese. I will share with you just one of many irreducibly complex biological systems that is necessary for life. This is the biological system that we take for granted every day, our blood clotting, which is called the coagulation cascade. Our blood clotting requires many complex protein molecules all in the right amount, in the right place, and all present together at the same time. Without any one part of this exact interaction, your blood would not clot or not clot fast enough and you would die from a small cut. On the other side of the spectrum, your blood would not stop clotting and you die from a massive blood clot. Here's a simplified version of our blood coagulation cascade. Blood clotting can be activated by two different routes called the intrinsic and extrinsic pathways. In the intrinsic pathway, all the proteins required for clotting are contained in the blood plasma. In the extrinsic pathway, some of the clotting proteins occur on cells. Now let's examine just the intrinsic pathway. When a person is cut, a protein called the Hagman factor sticks to the surface of cells near the wound. Bound Hagman factor is then cleaved by a protein called HMK to yield activated Hagman factor. This activated Hagman factor converts another protein called prekallikrein to its active form, kallikrein. Now kallikrein helps HMK speed up the conversion of more Hagman factor to its active form. Activated Hagman factor and HMK then together transform another protein called PTA to its active form. And activated PTA in turn, together with the activated form of another protein called convertin, switch a protein called Christmas factor to its active form. Next, activated Christmas factor together with antihemophilic factor, which is itself activated by thrombin in a manner similar to that of proaccellerin, changes Stewart factor to its active form. Stewart factor along with accellerin cleaves prothrombin to thrombin. Before this can happen, however, prothrombin must first be modified by having 10 specific amino acid residues called glutamate residues changed to carboxyglutamate residues. This conversion requires another protein molecule called vitamin K, which you've all heard of, and this allows the prothrombin to bind to calcium, which allows the prothrombin to stick to the surfaces of cells. Only this intact modified calcium prothrombin complex bound to a cell membrane can be cleaved by activated Stewart factor and accellerin to give thrombin. This thrombin can now cut off pieces from fibrinogen to form fibrin, which forms the sticky meshwork which traps blood cells and forms the clot. The fibrin stabilizing factor protein, which is also activated by thrombin, forms cross-linked bonds between the fibrin molecules to strengthen this clot. This highly integrated biomolecular function of blood coagulation is by definition an irreducible complex system. And just like the mousetrap, without one of these protein molecules, the system is non-functional. Each individual part by itself has no functional benefit to the organism. So you see, there's no way for natural selection to work to enable Darwinian evolution to randomly produce such a complex biological system. When we read to our children about the princess kissing the frog and turning him into a prince, we tell them that this is just a fairy tale. But our children are taught in school that when the frog is sprinkled with the pixie dust of billions of years, it does turn into the prince, and they call this evolution. You see, evolution is just a fairy tale for adults.